All right, guys, we'll get started. Welcome to the Lync Enterprise Voice session. My name's Nathan Chapman. I'm the CTO at Generation E. And we've also got Damien from Generation E as well, a UC consultant. Generation E is a Microsoft Gold partner. We specialize in Microsoft UC solutions. I've also got joining us down the front, Andrew Aaronsing as well from MCS is here for a bit of moral support and answer any other questions. So in this session, we're going to start off with a bit of a history of, I guess, where enterprise voice has come from the Microsoft products and how that's evolved over time. We'll do a bit of a demo around the user experience side of enterprise voice. So we're going to be focusing on the voice part of that. So an enterprise voice, in case you're not familiar with the terminology, enterprise voice means telephony or the PBX features. Is there a bird in here? Enterprise voice is telephony features. Okay. All right, I'll go on. We're going to go over some basics of the enterprise voice architecture, so how Lync actually connects to phone lines and that sort of thing. And we're going to look at some deployment scenarios as well, so from a greenfields deployment to a coexistence scenario, and a few different ways that we can integrate with existing PBXs as well. We're going to do a demonstration of one of those scenarios where we're putting in an upstream gateway and interoping with an existing PBX and allowing us to do a sort of a seamless migration from one platform to another. Also some discussion around the resiliency options, a quick look at some of the aspects of network planning you'd want to think about when doing enterprise voice. And also what we call the last meter, which is around the devices and making sure that you're thinking about how your users are actually going to communicate. So what devices are they going to use for the telephony, whether it's a handset or a headset. So back in 2007, our mate Bill sort of spoke about Microsoft's vision for transforming communications. So if we have a look through what's happened in the last sort of 6 years or so, we can see there's some pretty significant changes in the world of communications. So I think an interesting stat I've heard recently is that 1/3 of all international phone calls are now delivered over Skype. So we've seen obviously a big transformation in the use of software to transform how we're communicating. Obviously Lync is a unified communications platform, so the voice that we're talking about today is part of that, so people still need to be able to make phone calls. We've got all the other modalities there as well, from instant messaging and presence to audio, video, conferencing, collaboration as well. So we started to see enterprise voice features back in OCS 2007. It was the core features that came in. We had some features like simultaneous ring back there. In R2, we got some of the call distribution features like team calling and response groups that allowed us to distribute calls to groups of people. Okay, that's the other mic. And in 2010, there was actually quite a big update in enterprise voice. So we started to see things like survivable voice as a feature, so we can deploy appliances out to branch sites and deliver enterprise voice with survivability to cover situations where you've lost a WAN link or access to the Lync front-end server. As you see, there was a bunch of other features added in 2010 as well. 2013, we also had some more features come in, so things like group pickup. We also started to see the ability to do IP voice and video on mobile devices as well. And also Skype federation, so we can now do audio calls through to those millions of users out on Skype as well. All right, so I'm going to just switch over, just give you a quick overview of some of the voice features in Lync 2013. So this is the Lync client. Again, I was going to focus on, I guess, the enterprise voice features here. So if you've been using Lync and you haven't enabled enterprise voice, there's a couple of things you might not have seen. So one is this phone tab at the top. On that tab, we get a dial pad there, and it presents our voicemail. So voicemail in a Microsoft UC platform is actually part of Exchange. It's part of unified messaging. And it presents in your inbox in Outlook, but this is just another view of that, basically a filter view showing your voicemail. We've got options here, so we can, from here we could call into the voicemail, we can go and change our greetings and that sort of thing. To dial a phone number, we don't necessarily need to come to this tab and sort of use our mouse to dial these numbers. We simply just dial in a number, or even if it's a number like 13 cabs, you can sort of type that in and it sort of figures out what those letters correspond to. Hit enter, and it goes off and dials. And once we're in a call, we've got call controls here. So we've got a dial pad for our DTMF tones. We can switch audio devices. We can do call transfers. We can transfer a call out to our mobile, out to someone else, or even park a call as well. We've got call park functionality. Down the bottom here, we've got something else that lights up when we enable enterprise voice around our call forwarding options. So at the moment, I have my call set to simultaneously ring my mobile phone. So whenever someone calls my landline in Melbourne, it simultaneously rings out to my mobile phone. Now that doesn't necessarily mean I need a mobile client on my phone. If I have the mobile client on and I've set it up for IP voice, then it can do a data call out to the phone. But if that's not available, it simply just does a call out to a mobile number like a normal phone call, a simultaneous ring. And there's some more advanced features there for call forwarding as well. So on this page here, users can very easily change their call forwarding, and it's very easy to just understand what's happening. So there's a plain English description here of what's going to happen with my call. So at the moment, it's saying the calls that ring my work number are also going to ring my mobile. After 20 seconds, it's going to go to my voicemail, and that applies only during working hours because I don't necessarily want my work phone number just to be ringing my mobile after hours. We've got features in here like team calling. So team calling is kind of like an ad hoc hunt group that a user can set up themselves. So if I'm in the accounts department, for example, I can set up a team call for the other people in my department. And at the moment, I've set that and I put Damien in my team call group. So at the moment, calls that ring my number are also going to ring my team after 10 seconds. So if I don't answer within 10 seconds, it's going to call the rest of the people on that team. But then still after 20 seconds, it's going to go to my voicemail, and it's only going to do that during working hours. So very simple controls for users to configure their call forwarding settings. Now this is, of course, the Lync client and using it as a soft phone. We're going to talk about some other devices as well towards the end of the presentation, but there's a whole heap of devices. So you don't have to use your PC and a soft phone for everyone. There's a bunch of devices for different scenarios, for common area phones, for different places you need to get telephony features out to. So I'll switch back to the PowerPoint. All right, so I'm just going to talk a bit about some of the architecture of how Lync actually connects again to phone lines and some of the terminology that we use when configuring and deploying Lync. So in Lync we have what's called a topology, so that's basically a map of all our infrastructure for Lync. And there's a few key elements that relate to enterprise voice. The first is what's called the mediation server or the server role. The mediation server role, it usually coexists on the Lync front end. So the Lync front end is your main server role, the first role you would deploy. So it's not necessarily another server, it's usually just that coexists on that same server. There are scenarios you might want to split it out for some reason, maybe for large scale or something. But that role, that does a couple of things. First of all, when we get a phone call come in, it looks at the phone number that was dialed. It looks up in Active Directory and figures out what's the SIP address for that phone number. So it does that sort of number to SIP address translation. It can also do transcoding as well. So in some scenarios, we might need to transcode between audio codecs from maybe RT audio to G711, which is what we'll talk as a codec from on the telco side. So the mediation server will connect to what we call in Lync a PSTN gateway. The PSTN gateway, that's what it's called in topology. It can be a number of different devices. It could be a media gateway that connects to like an ISDN service. So it talks on SIP on one side and then ISDN on the other. It could be a session border controller, which is something that talks SIP on both sides, but it mediates different sides of the SIP communication. Or it could even be another IP PBX, so it could be a Cisco call manager or something that from a Lync point of view, we treat that as a gateway. That's where we're sending our phone calls to. We also have a concept of a trunk. So in Lync topology, the trunk is the association between a mediation server and a PSTN gateway. The reason we have that is because we may have scenarios where we want to have multiple gateways and multiple mediation servers and have different trunks going different directions for resiliency. So if we lose any one of these components, we can still get calls out by rerouting through different directions. Okay, so have a look at, I guess, a few of the three sort of key deployment scenarios. The first is where you're just retaining the PBX, so you're not really integrating Lync with the existing telephony. You plan to deploy it. You're not really using enterprise voice in that case. You're probably using it maybe for IMA presence and audio and video calls and online conferencing. Connecting with the PBX where we do some integration and then replacing the PBX, which is a cutover or maybe a greenfields deployment. So we'll look at them in a bit more detail. So with retain the PBX still continues to be the primary voice platform. And again, Lync will probably serve IMA presence, your PC, audio, video, and conferencing. So there's no integration there. So for your telephony users, you're going to continue to have to provision them on a separate system and manage them separately to all the settings in Lync. So Lync, you'll provision from Active Directory. You have that one common identity with Active Directory. So you still have quite a bit of admin work to do because there's still two completely separate systems and there's no integration between them. So we're not really unified in that case. But you're getting the advantages of getting IMA presence and some conferencing. The second is where we're connecting with the PBX. There's a couple of different ways we can do that. One scenario is what we call remote call control. So remote call control is remote controlling a telephone system. So we can do this on a number of systems. The PBX vendor will expose APIs and protocols that will allow Lync to be able to communicate with that and remote control basically your handset. So we can do things like click to call from Lync. We can control the call transfer and the forwarding and things like that from Lync. So in the Lync client, we've got our contacts here, and if you go to make a phone call, this is actually showing that my preferred calling device is actually a phone. It's actually a PBX phone. So when I make a call, the PBX still owns all that communication, owns all the media control and the call control, and Lync is simply just remote controlling that. One cool thing about that is that we do get presence integration. So because Lync is controlling your phone calls, it actually knows when you're in a phone call, even if that's on a different system. So when you're in a call, your presence status will change to red and show as busy in a call. Remote call control is actually mutually exclusive to enterprise voice. So technically in this case, we're not using enterprise voice because Lync is not making phone calls, it's just remote controlling something else. It sort of falls in the same category from a licensing point of view. It's the same license that you need to enable this functionality. So the other scenario is where we're doing integration with the PBX through SIP. We can either do what's called direct SIP integration. So that's where Lync is talking to your PBX and they've got, they're probably on the interrupt program so that they can talk directly without any device in between. So that establishes a trunk in between the two systems so we can place calls between them. If we can't do it direct, we can do it through a gateway or a session border controller. So the gateway, again, it might talk to Lync using SIP, but we may interface with a PBX using ISDN or QSIG as a different protocol to connect. This scenario also can be quite useful for enabling dial-in conferencing. So dial-in conferencing, we find a lot of customers are quite interested in. There's often quite a big return on investment opportunity around bringing teleconferencing back in-house. So some companies spend quite a lot of money with external conferencing providers where they're paying sort of monthly for hosted conference calls. So Lync has all that capability built into it, and you could use your own phone lines, especially if you've got multiple offices around the country or around the world. You can have dial-in points in all your offices and host your own conference calls. And they're not just teleconference calls, you can be video and content sharing and everything. So we see a lot of customers quite interested in that capability. So they might deploy Lync alongside the PBX, get that integration with the PBX so they can use the same phone lines that the phone system has today, and use that as a way of bringing calls into conferencing in Lync. Once you have that trunk there as well, that connection to your PBX, you're also in a position to start perhaps piloting enterprise voice users. So you can, if you configure your phone system to send certain phone numbers across to Lync, you can have those users be using Lync as their phone system. And it's a good way to start doing it like a pilot group without sort of necessarily doing a full cutover. So that direct SIP scenario, we've got a PBX here. There's a trunk there to the telco and phones hanging off that. So this is where Lync is just directly talking to that PBX. And there's an interop program called the UC Open Interoperability Program from Microsoft. There's a slide on it later on. But if you have a look on there, you'll see all the different PBXs that have gone through certification and testing for these different types of interop. The upstream gateway is probably a more common way to do this integration. It's what we usually prefer. So that in that case, what we're doing is we're putting a gateway in line with that existing connection. So we get in between the telco and the PBX, and we put a gateway in here. So these gateways, Damien's going to talk a bit about them. They're a third-party device. It's not a Microsoft product. So I think Sonus is downstairs an example of one of those gateways. So once we're in here, we're now seeing all these calls going through. And we can connect Lync to that gateway. So we use SIP on this side. Now this doesn't have to be ISDN, by the way. It could be a SIP trunk. It could be SIP here and SIP here and SIP here. But more commonly, it's usually ISDN is what most people have these days. So in this case, we're connected to all systems. So we're now in a position to start picking up phone numbers as someone calls a phone number here. If we want that person to be moved on to Lync, we can send it into Lync and talk to them, get them to talk to their device. Damien's going to go through a bit more detail on that scenario and how we actually migrate users as well. The last scenario was replacing the PBX. So one might be a greenfield deployment or greenfield site. And the other approach with replacing is where we're doing a flash cutover. So we might have an existing phone system there. It's got phones hanging off there. We can deploy Lync in parallel. So we deploy the Lync servers and get the gateway up and running, do our testing internally. But to switch over all your users, what you simply do is just move that connection from the old system to the new one, and the old one goes away. So that's a flash cutover. Obviously, there's a lot more planning because all your users are going to be cut over at one time. But if you're doing that, typically what you do is you roll out Lync to the desktop. So they'll be using Lync for IM presence and audio, video, PC calling beforehand, so they're quite familiar with it. And that last step is just all of a sudden it's going to start taking their phone calls as well. All right, so I'm going to pass over to Damien. He's going to just show you some demonstration on integration with the gateway.
Thanks, Nathan. Okay, so talking on that gateway upstream model that we talked about, that's probably one of the most common ways I see Lync integrated into an environment. We have an existing PABX system, and we want to get Lync in there, period of coexistence while we migrate users away from the old system. It's also seen as commonly the path of least resistance. So just to give you a rundown on what we're going to do on the demo. Effectively, we've got this as the existing environment and then customer side. We'll put that gateway in. I'm just pointing out this here. You'll see this in a second on the gateway that we're going to be using for the demo. So this is effectively signifying port 1 traffic, which is this trunk here, and port 2 traffic, which is the traffic between the gateway and the existing PBX. It's worth noting as well that when we put this gateway in line, it's completely transparent to this device. So as far as this device is concerned, it's still connected back to the PSTN. It doesn't know that this device is there. Once we do that, we like to integrate the gateway into Active Directory. So what that allows us to do is as we move users from PBX to Lync, it's a dynamic change. We don't have to jump on the gateway, update a routing table just to get users to start routing or calls to route into the Lync environment. As shown before, Lync sits off the gateway via SIP, and we start to get that integration this way. And I'll also talk a little bit about getting calls from this disparate PBX system back through the gateway, back to the Lync environment. Okay. So on the screen here we have a monitor page on one of the Sonos gateways. So any of the gateways are capable of doing this. So those ports that we were looking at before are these two here. So we've already got this gateway sitting in line with the PBX. So effectively calls are going to come in on this port 1 from the telco. And at the moment, because we haven't moved the user to Lync, it's going to pass through to this port and pass off to the PSTN, to the PBX system. So I'm just going to get an inbound call coming in. There we go. I don't know if you'll be able to hear this, but that's picked up a channel coming inbound, ringing on the PBX.
Hi, you've called Damien from Generation E. We're at TechEd this week, so yeah, I'll call you when I can.
Okay, so what we've done there is a call's come through, it's passed through. What's happened behind the scenes is that we've actually got the gateway talking to AD. The gateway, as it's come in and hit the rule, we can actually do a test here. We've got an ability to test our AD integration. So the username is, So doing an AD lookup test, it's found the name, TechEd user, but there's no phone number associated with that user. Now we're ready to move that user to Lync, move them off the old system. So here's a user that's been created in Lync over the control panel. I've already created the user just to make it a bit speedier. Just going to copy that phone number. It's probably worth pointing out as well that notice here that I've got the user enabled for enterprise voice, but I didn't have a phone number in that field. So in that scenario, that user can still make phone calls out. However, they're not going to receive any calls because they don't have a phone number associated to them yet. So that's quite a good intermediary step if you want to get users used to calling out from Lync from a training perspective. They can get used to the field, get used to the client without receiving inbound calls in that system yet.
By the way, that telephony mode there is also where you set them to, if you did want remote call control, that's where you would set that. Do you want to drop down that box?
Yep.
The enterprise voice. So there's a few different modes there. You can have PC to PC only, which is just audio and video between your computers. That's what you'd normally have if you don't have enterprise voice. You can actually disable audio video if you want to. There's remote call control. That first remote call control mode allows you to still do PC to PC audio and video. The one that says remote call control only sort of blocks the audio video part, so you can only do controlling your telephone. And then there's enterprise voice. So that's what I meant by that they're mutually exclusive. You can't have enterprise voice and remote call control at the same time.
And if we only had the user enabled for PC to PC only, back on the Lync client that you saw with Nathan's demo, this button here disappears from the client. So clients don't see options that they aren't able to use. Okay. So now they've got that phone number in, we go back to the gateway and just run that test again. You notice now that the phone number is popping up. So I've got this gateway set up for online updates. The gateway is also capable of caching AD information, so you can have like a USB stick in the front. So if for some reason it can't get to AD or get to the DC, it's still able to cache that information. Okay, so
you'll notice also that the phone number is it's what's called E164 format. So it's the format with the plus country code. So it's a global standard format for doing phone numbers, which is important when we're deploying Lync, especially on a global scale, that we have a consistent number format across the world. Because then if we know what the syntax of that number is, we can put rules and logic around that about how we route our calls and how we normalize phone numbers. So you'll always see in Lync that, we should always see in Lync that when you type in a number, like I called 13 cabs before, it normalised that number, so it actually put the +61 in front of it. So that's based on some rules that we configure, so that you can still dial the numbers as you'd expect to dial them on any PBX or however you're used to doing it. So you keep the same behaviour, but on the back end we convert everything to E164, so we've got a standard format for routing calls.
Okay, so I'm going to go back to the monitor tab and I'm going to call into the same number now. So you now notice here that we're getting that channel pop up in Lync. The gateway has checked AD, seen that I've actually moved this user to the Lync environment, and now I'm getting a toast pop up here. I can answer that call. You see these channels go green. Show you some additional call information. see calling in from my mobile, calling into this number, and where it's coming from.
So once we've got this gateway in place, often when we let the customers go ahead and do their migration in their own time, because all they need to do is just go and enable them users for enterprise voice. They don't need to worry about coming back and reconfiguring a gateway every time, because we're using that AD integration to dynamically determine when that user's been moved.
Let's go in that call. Okay. So that's fine for calls coming in. So calls come in from the outside world, hit the gateway. We have that AD integration. We haven't had to change any of the configuration on the gateway, but we're able to get calls routing to the Lync environment. We also, just flick back to the slides. So the other scenario is, so these systems are completely disparate. They're not aware of each other. So we need to also get calls going this way and also back from Lync. For the Lync side, the important point with the E164 numbering and the fact that the dial plan changes extensions into E164 format prior to dialing the number means that when this person calls an extension that's on this system, say they dial 100, normalizes into a +613 9413 number, Lync does a reverse number lookup on Active Directory to see is this person on Lync. If they are, I'm going to route the call to their CPRI. If it isn't, it's still a full E164 number, so a number that can be dialed and go out via the gateway. So what actually happens is Lync will send the call down here thinking it's an outbound call. We have some rules on the gateway that say, I know this number range, this is not an external range. I'm going to manipulate that into what the PBX wants to see. Oops. And I'm going to send it towards a PBX system. So as Lync is kind of inherently integrated into AD, that's not a problem, that's all done. How do we do it this way? Okay, so let's put some numbers on the screen. So here we have the old extensions. Now we have the new extensions that we want to use in our E164 format. So what we do commonly on systems, and the reason we do it this way is that when we have a gateway upstream, it's advantageous from an administrative perspective to limit how often we need to make changes to this system. If we have to talk to the telco, particularly if it's an external contractor or something like that, every time we wanted to move a user from PBX to Lync, it gets expensive, it gets time consuming. So what we do, we kind of put a call forward on this phone. So the phone number actually stays configured in this system. So we put a 0 in front of it and we send it to the full number. What this does is, this user here will try to call this user, doesn't effectively go to the phone and look at the routing table on the system here, and sends it outbound because we've got that 0 code and an 8-digit number or a 10-digit number depending on the telephony system. So effectively the PBX is tricked in a way, I suppose, to send the call out towards a PSTN gateway. The same logic as we used back the other way. This manipulates the number into E164 and sends it up to the Lync user. So these two users are talking to each other as if they're internal users. Numbers are still displayed to the user the way they'd expect to see it. So for a Lync user, they wouldn't see 1001 come up on their screen. They'd see a call from +613 9999 1001. Okay. Any questions on that configuration at all? I know this is usually the part I have the most whiteboard sessions about when deploying. Any more questions about it, or if you want to look at more of the configuration, we'll be downstairs showcase from 3 to 5 if you've got more questions. Okay. Voice resiliency. So introduced back in 2010 was the concept of voice resiliency, making sure that we're capable of still at least having voice calls functional for our users, regardless of whether we lose a back-end pool or have some other kind of failure. Okay, so the concept of voice resiliency, again, making sure that we haven't got that single point of failure in our system. We've got some key concepts. So we're going to talk about sites. We're going to talk about media bypass, which is an important feature of Lync, particularly in resiliency, keeping bandwidth intensive codecs off our WANs effectively. The survival branch appliance, we're going to talk about that a little bit more, and also the Lync client resiliency mode. So if I do have a site with a survivable branch appliance and I lose that WAN connection back to my main pool, the main site, what's the client experience? How does the client get affected? Okay, so first thing I'll point out is in Lync there's a concept of a central site and a branch site. There's also network sites, and there's a few other different sites. So the term site is used a little bit loosely. There's a few different, I guess, definitions depending on what part of Lync configuration you're looking at. For the sake of central and branch sites, a site in Lync has to have some Lync infrastructure at it. So if I've got a central site and I have a Lync pool in that central site, I have my conferencing, I have my response groups, I have my users, my registrar, mediation. That's the definition of a central site. A branch site, looking at this medium-sized site, we might have an SBA there. So a survivable branch appliance, which we'll talk about in a few slides, has a subset of Lync features that enables voice resiliency, but doesn't have all the functionality that we get from our front-end pool. We also have a small site, which isn't a Lync topology site. We might not have any infrastructure there at all. And if we have a branch site that we consider large enough to warrant its own conferencing engine and more functionality without reaching out to the WAN, we might deploy another pool or standard edition server or something like that in that location.
How many users would you expect to be in a large site to validate deploying their server?
Okay, just to repeat the question, like how would we validate when we'd actually put some infrastructure in a site? You can look at the sizing. So like for an SBA, that's up to 1,000 users. So these are all American numbers as well. So what we consider a large site in Australia may not be considered a large site in the States. But a SBA is capable up to 1,000 users. A small site, in my opinion, might be 25 users. A large site, for a company here, it could be 500 users. I think it's more important to understand the users that are using the system and also any kind of WAN constraints or something like that to justify having equipment sitting out here. There might be some customer sites that have 300 people in a branch that don't think an SBA is a requirement. So there's a few different ways to look at it. So with the branch site, so in a small site here, users get most of their functionality, or all their functionality, from this pool here. They register here, their conferencing's here. In a medium site, they're able to register in this site, but they get everything else back from the central site. Okay. So media bypass. So talking a little bit about media bypass, Nathan talked about the Lync server containing that mediation role and its ability to do transcoding as well. Even though it can do transcoding, it can be CPU intensive. So if we're transcoding any media, if anyone's familiar, video conferencing systems with big MCUs tend to be expensive, lots of resources. So the more that we can minimize transcoding, the better it is for the environment, or we don't need to have such a large amount of hardware to support user functionality. So effectively what media bypass is, quite simply, is we bypass, where we can, the mediation server. So all our signaling is still going through this server, which is not resource intensive, but we're able to send our media directly to supported devices. So looking at the UC/IP interoperability, this device needs to be able to support that. So we're actually sending G711 codec directly from a user to the gateway, which goes out to the PSTN network. Why is this important for voice resiliency? In the event that we have a server failure at that site, so in this case Sydney, our signaling might change paths and kind of go this way, but we're still able to send our media directly instead of hairpinning our media back down to this site and keeping that traffic off our WAN links. Another scenario, if I wanted to use that gateway, so in this case, my media is going to a gateway in a different site. In this case, this isn't media bypass. This is when we send the media in a skinnier codec to the mediation server here, and the mediation server does our transcoding for us and sends it to the gateway. So this ensures that we keep traffic off our WAN, and the mediation server does a little bit of work. Okay. So the survival branch appliance. So before we're looking at the Sonos gateway interface, and that is part of the story with an SBA. So you have that gateway component. Inside the chassis in a survival branch appliance, you also have effectively a full Windows Server 2008 R2 instance. it's running Microsoft Lync. It's running a subset of functionality. So as we talked about before, the front end runs all your conferencing and a whole bunch of other services, IIS for your web services, things like that. The server component on the SBA is running mediation, so it's able to transcode locally, and registration. So my Lync client can register locally at that branch site. Everything else, service-wise, comes from the front-end pool. So this is just some examples of boxes out there. Again, look at the UC OIP website. We've got a slide on that later on, and that explains or outlines what's supported with the different versions of Lync. Resiliency mode. So we talked about having the SBA in that site. If we lose that WAN link back to the central site, how does that look to the end user? So this is very similar to 2010, effectively the same user experience. So in this case, we have an SBA sitting out in our branch site. In our central site, we have our pool. User is registering against the SBA, but the rest of their services are still coming from over here at the Lync 2013 pool. So what I wanted to show here is that signaling-wise, we're still registering against the SBA, but we're getting all our user services here.
So user services, to clarify, I guess, is things like presence and conferencing and the other more advanced functionality, whereas the registrar can provide the basic call control. So be able to do the signaling for making and receiving calls, for transferring calls, putting them on hold, and that sort of thing.
Okay, so one of my colleagues, Greg, gets his mug on the screen. So in this case, we registered locally against the SBA. We've got no error messages or anything like that. Business as usual. In the event that we lose that WAN connection, Greg's still able to sign in because he's registering locally to the SBA, but you'll notice this message that pops up. Limited functionality is available due to an outage. So effectively, Greg's in a resilient mode, so he's able to make and receive phone calls. We've got a table that has the functionality, what works and what doesn't coming up, but he is notified that not everything's going to work. That's also the case if we lost the pool, of course, still registered in locally at the branch site with the same message. If we lose the SBA component, business as usual for Greg. He's able to sign in against his backup registrar, which is this pool over here, and there's no error message because this is where all the user services were to start with. Okay, so it's just an outline of what you would expect to work and what doesn't when you're in a voice resiliency mode. So you see on this list here that you're still able to do quite a few of the tasks, voice functionality. So we've spoken about having the SBAs, and that's having a device at a branch site, but what we're seeing now, and what I think we're going to see more of moving forward in the next few years, is a concept of having SIP trunks out here for our PSTN, purely based on some of the advantages that SIP trunks give us. So if anyone's worked with a PBX system at the moment and you've got your ISDN line, you have issues with that ISDN service. If you ever called a telco to get that number forwarded somewhere else, and they might forward your entire 100 number range to one mobile phone for the afternoon, that's been quite a common scenario. Not great for business continuity. So in this example, we've got a central site model. So we've got a central site here and a central site here. This might be primary and DR. They can be active. There is another session that talks more about HA and disaster recovery scenarios for Lync later in the week. Okay, so in this scenario, I've got my phone number there with the SIP trunk. Just probably explain a bit more. We've got two gateways. We've got one here, PSTN gateways. I've got these branch users sitting here with no hardware whatsoever. So we've got a Lync mobile client, so the new mobility client, the normal client, and maybe a tablet. Calls are able to come in, they route in from the PSTN, route out via the WAN, and still manage to reach the user. What happens if we lose that gateway? So with SIP trunks and the ability to have business continuity, we can have multiple registrations, and our number ranges can move from one location to another dynamically in the event of a failure. So in this case, we've lost this gateway here. Our number range dynamically moves over to our second site, and via the WAN, we're still able to get calls to that user. So we haven't had to make a phone call to the telco and beg and plead to get our numbers put somewhere else. Similarly, the call is able to route to the branch site as well. What happens if we lose the WAN? Okay, so with the Lync client, the mobility client, we are able to sign in via the edge server. So this client here, even though it's sitting out in the branch site, also has a 3 or 4G connection. It's able to sign in via our edge server, which is our edge device used by Lync to support all our external functionality. So in this case, the calls come back out via the internet. So that's a SIP call. We've managed to get a SIP call back out to that user. We also have the ability, if we don't want it to go over the network, we could also have simultaneous ring configured for this user. They get a call out via the PSTN and it still rings on their phone. So there might be circumstances where a SIP call is not appropriate, whether it's bandwidth, whether it's any other concerns you might have about using that kind of data on a phone. You still have the ability to get that simultaneous ring call out to that user. So this is a scenario that we're definitely seeing more and more of. Less hardware on the edge and more kind of thought put into automatic and dynamic failover of services at our 2 central sites.
The other scenario there is also if your users either have a local internet connection or they might have a 3G or 4G connection they can get to. So as soon as a Lync user gets on the internet, they're back with full functionality for enterprise voice again. They can take their phone calls wherever they are. So what we're showing here, I guess, is a few of the ways that we can mitigate things like WAN outages without having to deploy infrastructure at the edge by using internet connectivity or simultaneous ring to mobile phones.
So I've got some recommendations here, some general recommendations, of course. When you're looking at Lync, we want to make sure those central sites are geographically separate locations. No point having them sitting side by side. Registrar pools are configured as backup pools for each other. So from Topology Builder, and again, that's going to be in another session in more of the HADR, we configure those pools or SBA in pool to be failover registrars for each other. And we also want to make sure that from a voice routing perspective, that we've configured our voice routes to have more than one route. So we want to make sure that we go to our local gateway. If we can't get to our local gateway, then we try another gateway located at a different site. One thing to consider is the impact of central site outage to response groups. So if you're in an environment where you have SBAs out on the branch, in the branch location, response groups are one thing that aren't survivable in the event of a front-end pool failure. Response groups live on the front end, so there's something to be mindful of. Okay. With that, I'm going to hand back to Nathan. He's going to talk a little bit more about network planning and things that you should take into account when looking to deploy voice.
So if you're deploying either audio or video onto your IP network, and especially if you haven't done so before, a good practice is to look at something like a network readiness assessment. So the network readiness assessment is a process of doing some modelling and understanding your users and what modalities they're going to be using, so how many audio calls, how many video calls they're going to be doing, and modelling that, defining different user profiles within your organisation. And then using some tools to often simulate that traffic on your network before you go and deploy these applications on there. And also looking at the overall topology of your network to make sure that it's suitable and it's going to actually run this new media application you're putting on your network. So yeah, again, particularly important if you're not already running IP telephony today, you need to think about that. There's a slide after this one I'll probably skip past fairly quick, but it's just a reference there for the different codecs that we can use and how much bandwidth they consume as well. Another thing you should think about is quality of service. So Lync was originally designed, and the codecs they used to be able to run on unmanaged networks. It was designed so the codecs could run on the internet where there's the quality of the network is not guaranteed. So there's lots of technology in there in scalable codecs and be able to scale up and down and introduce forward error correction and doing healing at the endpoints to make the audio and video sound and look better. However, best practice is that you still do implement quality of service, particularly on your internal networks. People have an expectation that when they have a phone call that they're not going to have a quality problem. So quality of service is the best way to ensure that. So within Lync, we've got a few ways that we can work with quals on the network. We can specify DSCP tags on different types of media, for audio, for video, for signaling. And we can also define the port ranges that the different modalities use as well. So that you'll do that in conjunction with your network guys to align that with the quals policies you have on your network. Another part of that that's actually sort of related to quality of service as well is the concept of call admission control. Call admission control is about determining how much bandwidth we actually want Lync to consume on our network. So if I have a 10 meg link between site A and B, I might say that I only want my audio calls to be 100 kilobits per second each and only go to a total of 1 megabit per second, so about 10 calls. So that's a policy we define in call admission control, and Lync will enforce that policy so that we don't oversubscribe our network. Another thing that it does is if we hit those sort of thresholds, there's a few things it can do. It may actually be able to reroute the call over PSTN or potentially even over the internet if we've got sort of different data centers and edge servers. So it's not necessarily just drop the call at that point. Depending on where you're calling from, you could actually reroute the call, and that's seamless to the end user. So to configuring call admission control is just a matter of mapping out your network, defining what your WAN links are, and how much you want it to use. It's for audio and for video as well. So when we're doing network planning, this is some of the goals I guess you want to be looking for in terms of your network performance. Again, it's in the deck there for reference if you want to download it. But this is, I guess, the optimal quality here. So key stats on jitter and packet loss and latency there. As I said before, we've got a few different codecs that Lync will use for audio. So there's wideband RT audio. So that's a sort of a high definition audio that Lync will generally use on internal calls. So you notice if you start using Lync for even just a PC calling, but also if you have it as your telephony system as well, that when you're doing internal calls, the quality of the calls are much better than a normal phone call because it's usually using a wideband codec. We've got RT audio narrowband. So one of the examples that Damien showed before, where we had a call going across a WAN link, we would probably want that call to be using a narrowband codec, so it's a much lower bandwidth than G711. So you can see the difference there. These figures, by the way, these are including a lot of basically all the overheads you need to consider, things like the payload, the IP header. There's also other parallel streams that go with that. Actually, there's RTCP. Actually, I'm not sure if that one includes it. There is an RTCP stream, which is sort of a metadata that goes in parallel to a call that actually sends back information about the call and the quality of the call. And that's how Lync can actually adapt to the network. Using this parallel metadata stream, it actually knows how much loss or latency is on the network at the time, and it dynamically adapts to that. There's a few other codecs we use for conferencing. So with conferencing, we actually prefer some different codecs. The main reason for that is they're less CPU intensive to encode and decode. We're doing conferencing, we've got lots of participants. As you saw before in earlier session, we can have up to 1,000 sort of participants in a meeting. We're decoding audio streams for lots of people like that. The G722 or Siren is actually a much more efficient codec for doing that. And G711 is sort of the industry standard. It's an uncompressed media stream that's sort of your general sort of lowest common denominator, and that's usually what we'll send out to the PSTN world. So the last section is just around the devices as well. And by the way, we've got a few devices down the front here from Plantronics that have kindly donated for giveaways, and a couple of other busy lights and stuff as well. So we'll take some questions at the end for those. What's wrong with this picture? This is you might recognise it if you do a lot of travelling. This is the Virgin Lounge. So I took this photo a couple of weeks ago. This guy. Hopefully you can't recognise him, but yeah, he was obviously on a phone call or a conference call of some sort, but he was using headphones, but they weren't actually a proper headset, so he was holding the laptop up to his mouth to talk into the microphone in the Virgin Lounge. so that's something you don't want to have, right? And this is why your device's strategy for a Lync deployment, whether you're just using it for PC, audio, video, and conferencing or telephony, is critical. And it's critical to the overall success of a project as well. If you don't get that device strategy right, your users are not going to be happy and they'll think the solution's rubbish. So there's a few different classes of devices. So in, I guess, telephone handsets, we have what's called the Lync optimized handsets. These were based on a spec that Microsoft developed. You notice probably that the screens on all of these are actually, they run the same software. So basically Microsoft developed a chipset and a software platform to run that was common across all different vendors. So they went to partners like Polycom and HP and Astra, and they said, here's our spec for a Lync telephone. Go and implement this and put your own sort of features around that. So obviously Polycom is quite well known for the audio quality in conference phones and that sort of thing. So they've got the only sort of Lync optimized conference phone. But the functionality on these sort of handsets you'll see is sort of pretty much identical, though. You basically got the same sort of buttons on them. So it's a common sort of user interface between them. And in these, there's what's called an information worker phone and a common area phone. So the common area phone is just sort of a cheaper version that has sort of less functionality. It's designed to stick in like a kitchen area or a meeting room or something. Whereas the information worker phone was designed for people who's sort of using telephony all the time. The next class of phone, one thing about these phones, I guess, is they're not very customizable. Everything is provisioned through Lync, so you can define policies and about how people can make calls and what numbers they can call and all sort of thing. And that they also have a hot desk mode as well that works quite well, so you can have them automatically log into the phone based on your credentials you sign in your PC. They actually have a USB cable that connect to your PC. So that they're quite good for certain applications. We're seeing more these days, though, that customers are starting to use sort of industry standard SIP handsets that have been tested and certified with Lync. So the Polycom VVX range, which you'll see down at the Polycom stand, they've got these on display. These have been certified for Lync so that they natively support Lync and will log in and take advantage of a lot of Lync's features. There's another one range here, the SNOM, that's also been certified. You can see there's quite a range of handsets, from an entry-level handset that's probably like $140 or so, or potentially less depending on your volume, up to sort of video phones, and there's also, this is a SpectraLink phone that's a Wi-Fi phone. There's also DECT wireless phones that are certified for Lync as well. So you've got quite a big choice of different vendors, different types of handsets suited for different applications. There's attendant consoles as well. Polycom is releasing a attendant console soon for the VVX range also.
Just before you
Actually,
go on, just back on this one, I just wanted to mention the page.
Yeah, so actually another feature we can do with these, because they're customizable, you've got things like custom buttons or soft buttons on these phones. So on the SNOMs, you've got sort of 20 buttons on here. You can do things like program like traditional busy lamp fields if you wanted to, which is essentially a Lync presence on that button. But you can also use them for things like paging as well, so, or push to talk. So you can page through handsets, which a lot of IP phone systems could do. So the other Lync phones, again, they weren't very customizable, so they didn't have some of the features that other PBXs had. Whereas with these, we're able to fill that gap and do things like paging, push to talk. We can put local music on hold files on these phones, and a lot of other custom features. And with paging as well, we've done integrations with other devices where we can integrate to external paging systems as well. And we actually do that through the gateway generally. Is that all you were going to add on it? And the other class of devices is sort of USB devices, right? So I think there's over 100 certified devices now from all sorts of vendors. Some of them up here. Again, you'll see some of the guys downstairs have got these sorts of wired and wireless headsets. There's devices like this, which sort of looks like a phone, but it's actually a USB device. So for people that want that look and feel of a telephone, but actually it's powered by the PC, you can use something like that. There's speakerphones like the Plantronics one there, and there's a Jabra one. They're really good sort of ad hoc conferences. I use that quite often when I'm in customer meetings and doing demos. So we're seeing a lot more adoption of these types of devices and using Lync as a soft phone because of the mobility benefits. You're no longer tied to a desk and to a handset. We're seeing it a lot in activity-based working initiatives where people are focusing more on social spaces in the workspace, and having a device like this allows you to go and do your calls and communicate from anywhere and not have to worry about moving a handset around. So we used to be about 30% of Lync deployments we'd sort of estimate were sort of soft phones. Now it's probably more like 50% and increasing. So we're certainly seeing a lot more uptake of using Lync as a soft phone and not deploying traditional handsets. There's usually always going to be handsets in a deployment for meeting rooms and that sort of thing, so they still have their place. But for a lot of your knowledge workers, you'll start seeing this used a lot more. We mentioned before the Open Interoperability Program. So this is a good place to check out all these different devices. So Microsoft has a program to certify headsets, telephones, gateways, session border controllers, wireless network equipment, switches, load balancers. So the URLs on there that you can get from the deck. But it's a good reference to if you're looking for different devices for your solution. All right, so that was the last part of our session. There's a couple of other references here that are in the deck for your reference to find out more information. And there's also a few other sessions you might want to check out as well. We mentioned a few. There's a session on contact centers. So we're talking about voice today. So the next step up from that is often the contact center requirement. So they'll talk about some of the options around Lync and how we can provide contact center solutions. There's a session with Telstra around UC in the cloud, so Lync in the cloud. A session on virtualization, that the DR session. Publishing Lync to the internet, so that's around deployment of the edge server role, and also some troubleshooting. So with that, we'll open up to questions. Yep.
Other than, I suppose, a PIN, what other authentication mechanisms are there for a phone?
Yep. So the first time you sign into Lync, you'll either need to authenticate with your AD credentials. Yep, sorry. The question was, what, other than an extension of PIN, what other authentication mechanisms are there to logging into a phone? So on a phone, you can use an extension of PIN. So you saw when you configured that phone number, there was a semicolon ext equals, and that's the extension you would use to log into the phone. And there's a PIN associated with that you can distribute out to your users, or they can reset it through a web interface. From the PC, you can log in with your AD credentials. But whichever method you use, the first time you log in, it actually automatically issues a user certificate to the device, whether it's a phone or a PC, which is quite important, and it's relevant to that survivability scenario, because we talked about these survival branch appliances and you're losing your WAN link and people can still sign in. You don't need a domain controller there to sign in, because it actually has, once you've logged in once, it's got a certificate, and it uses the certificate to authenticate. So I guess to answer the question, there is PIN extension, NTLM, Kerberos authentication, or certificate authentication. And it kind of depends on the device.
That certificate has a validity of 6 months. So if you're external and you have that phone, you might have some policies that don't allow certain types of authentication. So you know that a phone's had to be inside your organisation before it's been taken out onto the external network. 6 months.
Yep. Sorry.
There you go. Lync over wireless. Now, 2010 environment, a lot of problems with poor network quality.
Yep. So in 2013, they started as part of their interrupt program. There's a new wireless vendor interrupt program where they're actually certifying the solution and providing guidance for deployment on wireless. So in 2010, technically it actually wasn't supported on wireless at all. A lot of people did it, and you can make it work well, but there is wireless, especially doing voice on wireless, you need to deploy your wireless in a particular way that is ready for that. So there's a certification program. I think currently Aruba and Juniper on that program is certified, and Dell, which is a OEM Aruba. So those vendors are there. But again, if you look at the guidance in there and look at the principles that you're using with the infrastructure you've got, you can probably get a good idea.
So Nate, there is a new white paper on wireless.
Yeah, there's a general white paper as well.
And also talks about the changes in 2013 to kind of help mitigate any issues that existed in 2010.
Is this scenario where you're porting lots of legacy PBX and trying to do one extension at a time, doing it forward.
Yep.
We've got a problem with, we did trial that, and PBX is smart enough to realise you're sending it to your in dial and it's just statistics.
Yep, so I've seen that on a couple deployments. One way around that was we started sending it to 0 plus 10 digits, so 0, 0, 7 plus another 8 digits.
Like in dials.
Yeah, if that's the case, and that is one scenario where you want to talk to your PBX provider and say, hey, we want to remove the smarts off the system. So effectively the PBX is being too smart and basically stopping calls going out and doglegging back in. I have seen that. The solution for me was to change it to 10 digit with the 0. If that doesn't work for you, then it will have to be a change from the PBX provider.
In a fully enterprise environment, if, for example, a user is on leave or something, is there a tool or something which can be used to change, redirect the phone?
There is a
Can you
resource
just
kit.
repeat the question? Sorry.
Yeah, so the question was, if someone goes on leave, is there a tool to be able to change the call forwarding settings? There is a resource kit tool called Cepha-util. It's a command line tool. It actually runs as an application on the server. You use a command line to interface it. I think I saw someone's written a GUI interface for that.
Yeah, I was playing with that a few weeks ago.
Yeah.
So there is a GUI for that.
So yes, there is a tool. It was originally not ideal because it's command line, but if you grab the GUI tool that someone's written for it, it's probably not a bad solution. Peter?
I was just actually wondering, with the SBA concept, is there going to be one that actually brings out a 3G so we can eliminate the requirement of ISDN altogether?
It's interesting
Yeah,
that you mentioned that.
There is a new concept called RBA, I think the Resilient Branch Appliance. I don't know if Andrew, yeah. It's fairly new. If you want to go down, it's probably the best thing to talk to Sonus about it, and I'm not sure if Audio Code's down there as well, but they both have released the concept of an RBA. Generically what that is bound to detect that the WAN is down and reroute over 3G. What they're doing is dynamically updating call admission control so that your calls get rerouted over PSTN, but you keep your signaling back to the central site through 3G. So we're not putting media onto 3G. You keep the signaling there, so you still have IMM presence, and your calls get redirected over PSTN. That's probably the best way to describe it.
If calls are coming over PSTN, you're still requiring some form of networking capability apart from 3G though, aren't you?
Yeah, so there's still an appliance at the site, but the appliance doesn't actually have the Lync server. It's not an SBA. It's I guess a lower cost option for an SBA that uses 3G as part of the solution.
Question, what sort of licensing models available, like you license the users and hardware?
Licensing, Andrew, I might pass over to you on this one.
I'm on a consulting side, so I'm not licensing
Okay.
authoritative, but in general, Lync is licensed on either a per user or per device basis. Most organizations license it per user. You can have, once you're licensed, you're either for item presence, for conferencing, or for voice, right? One of those, the three general buckets. And then you can use Lync on any device that you might have. So if I'm licensed for enterprise voice, I can use it on my cell phone, on a tablet, on a laptop, and a desktop with no different license costs. And a user can only have a single number. The exception is there's a private line option with Windows 10 and 13 where you can have a secondary number which you give out as your private line.
With those customizable phones, what infrastructure do you need behind to customize it? What do you need from there?
Actually, I think the Polycom now are actually provisioned in band, so that the same way that the optimized phones get their settings and that sort of thing, it uses like DHCP options and that sort of thing to discover the server in DNS. So it used to require things like setting up an FTP server and config files. They've now got them up to speed and using the same infrastructure that Lync would use to discover the servers.
DHCP and DNS.
Yeah.
Aging and stuff like that, it's twice the cost.
Yeah, but if you're going to do customization like paging, then you would need to configure each device, and you could do that through creating a config file and pushing that through TFTP or something. So you'd create templates for different types of phones. Their phones also have GUI interfaces, so you can just go to the IP of the phone and configure it that way. But if you're doing it on a large scale, you probably want to.
What I mean is the phone doesn't need, if you want the phone to do something with one of those buttons, the phone knows how to do that. It doesn't need anything else behind it to talk to do
Not once it's configured.
So once it's configured,
Yeah.
once knows
Yep.
what it has to do, it can do it itself.
Yep.
Yeah.
It doesn't need another
So
server.
for paging, for example, it actually has nothing to do with Lync. It's actually doing a multicast between the devices. So,
That's the
Yep.
question.
In relation to that, can you set up enterprise policies to manage it, given the fact that you may have a large set of devices that you need to be deploying across your enterprise?
it's probably best to ask the vendors that
Yep.
let
Yep.
Polycom or SNOM
Yep.
So
about
no,
that question. Yeah.
Snom had a like a cloud-based configuration tool where
Yeah.
you could actually configure phones or have serial numbers from phones,
Yep.
configure them when they plug into the network for the first time. It actually gets its settings from the cloud. So whether you've got multiple sites or one site, you can still kind of configure all your phones in one hit.
When you install the monitoring component, does it also capture jitter when you call from external?
Yeah, so
or bandwidth?
actually, it's probably a good point. So when we do for any Lync deployment, there's a Lync monitoring server role, which we consider compulsory. It logs every communication and statistics about the communication. So there's part of that called quality of experience, and you can go through a web report and look at the network characteristics during that call. So that'll include the loss, the jitter, even what headset you're using. So sorry?
Even the endpoints that they
Yeah, that's right. So you can see even what CPU was on the PC. So there's a huge amount of information there for troubleshooting, that sort of thing. Sorry, you want to... Yeah, so the Lync wasn't designed itself to be a call center solution. So we work with some third-party vendors for call centers. So Zcom has got a stand downstairs, and I think there's a session. When's your session? Tomorrow. Yep. And I think Aspect are also part of that session as well. So they've been a partner with Microsoft as well. Yep. So we might need to wrap up. So again, we'll be downstairs from basically straight after this till 5 o'clock. So come past the office showcase. I'll be down there if you've got specific
And
questions.
thanks
but
everyone
I'll
for
take that
coming.
last one.
Thank you.